components of ERD, the major components of ERD before we actually draw a particular ERD. So I'll say components. The major components, as the name suggests, are entities. Okay, so what about them? Entities. Entities, anyone?
It's a real object.
Or real object. It seems like you have studied object-oriented programming.
What is an entity?
What is an entity? Entity, let's just cut the crap. Entity is table, that's it. I mean, I could say 10 different things about entity, like entity is a real life thing, it's an object, it's a falana and balana and ABCD and all that. But at the end of the day, entity in ERD diagram is nothing but table, that's it. Every entity that you are going to draw in your ERD must translate to a table. Yeah. And within entities, the symbol for entity is this rectangle that you draw for entity. And you must name the entity. For example, let's say user, or you could say student or something like that. Alright, so user and then student. Basically, this is your one table in your tables.
So what is a weak entity?
Weak entity. A weak table? Alright, that's a very pathetic joke, lame name from my side. Okay, so weak entity. I'll give you a very simple example that will make it really, really clear. Let's suppose there is this one table called as user. Assume the user of any social networking site. And then there is one more table called as a profile. Right. Now, the relationship between user and profile, perhaps user table will store information about user like user ID, username, email ID of that user, his age, gender, country, whatever. And the profile for that social networking site of this particular user will store the information like about him, his hobbies, maybe his profile pic, something like that, right? So all those information. Now, in any social networking site, if you see, each user will have one profile, right? So, but profile belongs to a user. That means profile cannot exist independently of user. If there is no user, there is no profile. So, this entity depends on this entity for its existence. So that also means that this entity will not have a primary key of its own, right? Profile, we don't need primary key because user ID will be its primary key. The foreign, basically these two tables will be related, right? User has a profile. They will be based upon some common column. Most probably that will be, if the primary key of user table is user ID, then that will be the primary key for profile also, more or less. Because we don't need separate primary key for profile because profile only exists because of particular user, right? When we delete that user, let's say you deleted your own account on Facebook, your profile information is automatically gone. It no longer exists. So that way we'll denote this entity as weak entity. This is the symbol for weak entity. So this entity totally depends on another entity, parent entity you could say, for its existence. And usually the weak entities do not have their own primary key. Usually their primary keys are the foreign key or primary keys of some other parent entity. Or their primary keys are composite key of including primary key of another table and one attribute from this particular entity. So we have talked about attributes in detail right now. Alright.
So now what are attributes you just said?
Okay, attributes. I'm really sorry that we didn't touch upon attribute earlier. So attributes are very, very simple to understand. Attributes are the columns of your table. So if entity is your table, then the columns of the tables are attributes. As simple as that.
Are there any types of these attributes?
Okay, you seem to have done your homework. Yes, there are some types of these attributes. The most famous and most known is primary attribute or primary key, which uniquely identifies a row in the table. So we usually denote that attributes are denoted by these ovals, right? And primary key is denoted by underlining the name of the particular attribute. This signifies that this particular attribute is the primary key. Alright? Then apart from the primary key, attributes do have certain types. So derived attribute is something whose value is derived from some other attribute. For example, my user table also has a column or attribute, in case of AID we say, as date of birth, right? And then I have one more attribute, something called as age. Now I'll denote age as a derived attribute. This is the symbol, the dotted or ellipse. It means that age will be derived from date of birth. Like we will subtract the current date from the date of birth and you will get this age attribute. So it is calculated from the value of another attribute. That's why it is called as derived attribute. Second is a multi-valued attribute. A particular attribute, for example, if you are storing something called as if you are storing tweet, awesome. So on Twitter, your tweets, they must be stored in some table, right? In tweet table, you have an attribute called as tags. Hashtags or tags. So one tweet can have more than one hashtags, if I am correct. Right. So one tweet can have more than one hashtag. So basically the multi-valued attribute is something like that. An attribute who can have more than one value. There will not be atomic, there will be multiple values possible. And they are usually denoted by this inner ellipse. So this is the notation for denoting multi-valued attributes. And then you have something called as composite attributes. Composite attributes are like, for example, we have in user table only, we have another attribute called as name, but we have split the name into two more child attributes such as first name and last name. So now name becomes a composite attributes, which can be further split into child attributes such as first name and last name. So your name becomes composite attribute. So this is the way you showcase the composite attributes. So these are pretty much the types of attributes.
Isn't there any attribute type for the foreign key?
Basically, the nice little answer for this question of yours is that we do not show foreign key in a EID.
Why so?
Okay, that's an obvious question and I have a very obvious answer for you. If I say that user table is related to profile table, let's say user has a profile, then they are related because they have some column in common. You always say that there is a relationship between two tables when there is some column common between the two tables. There has to be a foreign key involved, right? And foreign key for this table has to be the primary key of this table. Exactly, that's what foreign key is like. Foreign key of this table is primary key of this table. And primary key is already denoted, right? So if the primary key is denoted here, that means this automatically will be present in the profile table by some name, either by the same name or another name. Now, because we have depicted the relationship already, we don't need to depict the primary key column again. Sorry, foreign key column again. It is understood that this table is in relationship with this table. That means there is a common column, there is a foreign key, primary key. The primary key of this table is shown. That means this column will become foreign key for the other table in the relationship. So we do not really show the foreign key separately. So yeah, let's discuss the same example that we have currently on our hands. Types, I would say, is like there are three popular types: one-to-one relationship, one-to-many relationship, and many-to-many relationship. These are the three most popular types of relationship, if you were to say, or I would say these three are the cardinalities that are available with respect to relationship. Now, so let's discuss which type of relationship or which type of cardinality is there in between these two entities and their relationship. Now imagine one user, give me the answer of this question. One user can have how many profiles?
One profile.
One profile? One user can have one profile. So one user can have strictly one profile?
Yeah.
Can we say strictly one profile? because we are going to use something called as this Krauss
Notation.
foot notation to denote the cardinalities, right? So we say one user strictly has one profile. So this is the notation for strictly one. 2 times 1 actually, but strictly one. And one profile, one particular profile belongs to how many users?
One user.
Strictly one again.
Strictly one. One profile strictly belongs to one particular user. So again, one profile belongs to strictly one user. So this is the way I denoted this cardinality. Now this is really one-to-one relationship. This is a nice example of one-to-one relationship. One user can have strictly one profile. One profile can have strictly one user. Again, do not confuse this with, okay, I can have, open multiple accounts on Facebook. Facebook treats you as two separate users, even if you are the same person, right? For them, these are two separate users. Alright, so that is one way, one-to-one relationship. Then you have, as we said, one-to-many, many-to-many, right? Then we'll draw full-fledged hierarchy. At that time, we'll again study those, right? So I'll just tell you the notations right now. One-to-one relationship is depicted like this. One to one, right? It's really like this, strictly one to one. Then another type is one to many. That we usually denote it as one to many, right? Crow's foot. Okay, so this actually looks like crow's foot, not cow's foot. Okay. I haven't seen both of them in a while, so sorry for that. So, yeah. But it's not even that simple. Now we have like,
No.
let's say,
Producer and movies.
user and emails, email IDs.
No. How we can take that?
What?
How we can take again? It's the same previous example.
Email IDs. One user can have many email IDs. One on Yahoo, one on Google, one on Outlook, right? One user can have, maybe some of the users do not have email ID, right? I think you don't have any email ID. Right. So one user can have 0 or more email IDs. So notation is like this, 0 or more email IDs. One email ID, now take the reverse relationship. First we go forward from one entity to another, then we go reverse. So, one user has 0 or more email IDs, right? One email ID belongs to
One.
strictly one user, strictly is a word.
Yes.
One email ID belongs to strictly one user, so we denote it like this. So this is the correct cardinality. It's actually one-to-many relationship, but we have also included this 0 and strictly one to make it more specific. Now we have discussed one-to-one, one-to-many, now we'll discuss many-to-many. So, any example for many-to-many? As we can name. This is naming, by the way, nobody asked this. I'm just doing this diamond is nothing but name of the relationship. I will talk about it more when we draw here. Yeah. Many to many. An example, many to many.
A director or a producer and his movie.
Right. So movie producer and a movie. So how do we depict the cardinality for this? A producer can make
Many movie.
One.
even if you make one movie, you become a producer,
Yeah.
right?
Of course.
Yeah, lifetime achievement award.
Yeah.
So one producer can make one or more movies. See the symbol now, 0 or more, 1 or more. So this is the symbol for one or more. Right? So one producer can make one or more movies. Now we go reverse. One movie
Can we make by
is made by
more than one producer?
at least one or more producers.
Yeah.
So one or more producers. One producer makes one or more movies. One movie is made by at least one or more producers. So that is many to many. ERD for bbarters.com. Alright. So this is our software, bbarters. Okay. So first entity that I want to draw is user. Most important table in our database, or any database for that sake, any software database. What about its attributes? Do you want to help me with that?
It has an ID.
It has to have the ID, user ID, something like that. Okay, so I'll just say user ID.
Then there's the name.
I presume user ID will also be the primary key.
Primary.
Right. Then we can say there's a name of the user, and we can further decompose it into first name.
Compose it.
Yeah, correct. We just studied that. You have a good memory. Last name, right?
Date of birth.
Maybe we can have date of birth, and then we can derive age from it, right? See, the first step in drawing any ERD is that identify your entities and draw them. Identify the entities and draw them first, and then think about relationships. Yes.
Is there any rule for draw attribute only upside or?
No, nothing like that. You can draw the attributes anywhere and draw them as small as possible, and you don't even have to draw them. Some top level ER diagrams do not have attributes, just to keep them clean. If you see, this is going to get really messy now. You know, all the attributes and all the relationships. So many times you will see that there are no attributes shown in an ERD, and you might just say, oh, that's incorrect, but that's not really. It's just the level of abstraction that they are maintaining. Moving on. Next entity.
Profile.
Profile. That sounds good. Okay. So profile. As I discussed earlier, profile is going to be our
Weak entity.
weak entity, because profile totally depends on user, right? Then profile, any attributes that you can think about?
Profile pic and about me.
Yeah, about me, something like that. Yeah. About me, and maybe what's your profile pic? When we say profile pic, it's going to store the part of the profile pic, right? Actually, you can store the entire image also. You can blob, so that's okay. Profile pic. Any other entity you can think about?
It's a blog.
Blog, yes. We recommend writing some content on bbarters.com. So definitely a blog. Blog makes sense. Okay. Blog. What about attributes of blog?
ID.
Okay. Blog ID.
Title and text.
Title of the blog. Yes. Then text of the blog, actual content. We can say content.
Yeah.
Makes more sense.
And the tags.
And the tags. Yeah. I think tags will be multi-valued.
Yeah.
Right? There can be many tags involved associated with a particular block. Hash, karma, hash, karma2, hash karma3. Right. Alright. Then blog is there. Any other entity you can think about?
There are interests.
Yes. We advise or we recommend people while they build their profile that they should select some interest like technology or sports, girls.
Political.
Okay, political girls. Okay, that's a good interest. Keep it to yourself. Learn to keep it to yourself. So where do I draw this interest, right? Here somewhere? It's going to be a big ask for me to accommodate all this diagram within this tiny little board of ours. Interest. So interest has any attributes? ID, interest ID.
Name.
So let's say IID. Yeah.
Name.
Like CID. Name, interest name. That's about it. Okay. Any other entity that we can think
The
about?
last one, comments. Blog book.
Yeah. Blog really will have comments, but I'll take my time with it. Okay. So these are, let's keep it really simple. Not really simple, but 4 entities that we have identified in our bbarters.com software that we want to build. Right? Now user, profile, blog and interest. Now let's talk about relationship between user and profile. So as we already saw, user will user has profile. Simple. Now let's talk about cardinality of this relationship. One user has strictly one profile. So this is the notation for strictly one. one profile belongs to strictly one user. So this is a one-to-one relationship, and profile table will have a foreign key of user ID which we are not shown because there is a relationship, and it is implied that there will be some column of user ID in here. It is implied, so we do not show it. Fine. Now we are saying that profile is a weak entity because if there is no user, there is no profile, and profile doesn't have a primary key of its own. Right? It totally depends on its foreign key for its uniqueness. Right? Awesome. Next, we talk about user and interest, relationship between user and interest. What that should be? User chooses, right? Interest. User chooses interest. What about the cardinality of this? A user can have one or many interest, correct? At least one or many. One or many interest. He has to choose one. It cannot be zero or many. He has to choose one, then he can choose as many as he wants. Talking about reverse relationship. One interest belongs to zero or many users, correct? Can there be any relationship between interest and block?
Yes, there is.
Yes. See, if you choose an interest and technology, then you can write blogs about technology, right? If a user chooses interest of political girls, then you can write about political girls. I'm waiting for that. But you have to provide an interest. You have to say this blog is about technology. You cannot say this blog is about nothing. So there cannot be zero, right? One blog is about at least, or strictly rather, in our case it is strictly one. It's not like hashtag. So one blog is strictly about one interest. What about, can one interest have zero or more blogs?
Yeah.
Either somebody can write a blog about them, many of them, or people don't write about particular interests like political girls. Again, so one interest can have zero or more blogs. Awesome. It's also done. Can there be a relationship between user and blog?
Yes.
Yes. Obviously. Who is going to write the blog? Users. So user writes. Okay. I'm gonna need a lot of space down here. So I'm gonna show something like this. User writes blog. What about the cardinality of this? What about the cardinality of this?
One user
writes zero or many blocks.
One user can write zero or many blocks. If user is like me or say you, so user writes zero or many blocks, right? Now one blog is written by strictly one user, right? One blog is written by strictly one user. Awesome. Pretty good? Alright. So I would say, is it safe to say that blog will have a foreign key column
Called as user ID.
called as user ID? Do we show it here?
No.
No, because it is implied. Awesome. Then what about, is that the only relationship possible between user and blog? Do you think that user only writes blog and that's it? Okay, my job is done.
Suppose you are
He also reads the blocks.
He also reads the blog. Awesome. So user, one more relationship between blog and user. User reads blog. Okay, now it's going to be of this.
Zero.
A user can read
Zero
or many blogs. Right? So zero or many blogs. What about the blog is read by
many users.
zero or many users? Again same. So zero or many users. Real nice. So blog can be read by zero or many users, right? Now there is one more thing in our bbartist.com, that is your friends. It's a social sharing site. So people become friends of each other. How do we depict that relationship? Friends. Now who is friend with whom? Which are the two entities that are involved in this friendship?
Both the users.
Both are users. Like in Facebook, similarly like Facebook, right? You are both users of the Facebook, then you are friends. So in this case, user is involved with user in a relationship? That's really strange, right? And so that is user friends with
Zero.
users. Right. User is friend with users. Right. Awesome. So this is called as your recursive relationship. When the same entity is involved in a relationship with itself, then that is called as recursive relationship. Now, this is the way you depict recursive relationship. What about the cardinality? A user can be friends with
None.
Zero.
zero or more users. So zero or more. And then again, because there are two friends, first friend is having, first user can be friends with zero or more other users. The other user can be friends with other zero or more users. Awesome. So it's actually many to many. Right? Comment or comments rather strictly. A user comments on a blog. But then this comments relationship also has a data. He stores something, right? So we usually say this comment, there's one more entity involved in this relationship, that is comments. So this is an example of ternary relationship. In this comments relationship, there are three entities involved: user, comment, and blog. Three entities involved, so that's why it is called as ternary relationship. Now, how to show the cardinality? Now things get really interesting. User, now you cannot just simply say that a user can, but no. Now, if I want to write this cardinality, I have to consider user and comment together. For a particular user and a particular comment, suppose you made a comment. What? Take an example. Chuck it. It's a comment. Awesome. Chuck it. So this chuck it comment was made by me. So one user and a particular comment, chuck it, belongs to how many blogs?
One block.
That particular comment by that particular user belongs to particular blog. So you could say then it is strictly one. If you make that same comment somewhere else, that belongs to some other blog. So that is one blog. Now, if you want to write this cardinality, then you have to consider user and blog together. For a particular user commenting on a particular blog, how many comments he can write?
Zero to many.
Zero to many. For a particular user on a particular blog, he can write zero or many comments. Right. And then last here, then you have to consider these two together. For a particular blog and a particular comment on that blog, is written by strictly one user. This is how you really create your ER diagram, and it's really fun and it's really simple. Awesome. Thank you for watching this video.